the topic domain of a square root function, the basic version. Uh, and what we want to do is when we're ever talking about the domain of a function, what we're saying is what values of x can we use and we put in for x, what values can we put in for x that give us a real value, a, uh, a number that we can come up with, right? A real number. So the two things or two of the main things we watch out for is what can we not do mathematically. So it's kind of this thinking back and forth. Well, one of the things we can't do mathematically, or we've decided we can't do, is we can't divide by 0 because this gives us something we call undefined. And your calculator will tell you this. Now, if you look at it philosophically and long term, what does this really end up being? It's infinity. Later on, you'll see that, yeah, whenever you have 0 on the bottom, dividing by 0, it's actually a very large number, so it's shooting off to infinity. But infinity is not a real number. It is a destination that you never get to, right? The other problem we face is, with this one specifically, is square roots. When you're taking a square root, if you have a negative inside that square root, you can't find a real number that will do that, right? Because what is a square root? It's two numbers, or it's a number that multiplies by itself to get you the number inside. So, square root of 9 is 3. But if you try negative 3 times negative 3, you still get a positive value. So you can't get this, you can't get a negative 9. Like the square root of negative 9 does not exist in the real world. It is a imaginary number, so there's a whole mathematics that has been developed with this. But so what we're looking for is we can't have a negative inside here. So what we're going to see is we're going to take what's inside the square root, and we're going to say it has to be greater than or equal to 0. Non-negative. It can be 0, it just can't be negative, right? So this is what we're going to do for the domain. But while we're solving this, that's somewhat abstract in our thinking. What we want to do is let's take a look at the concrete version of this. So we're going to actually look at the graph using Desmos. We can graph this function as f of x, and I'm just typing this in with my keyboard. Notice we also have a keyboard down here, which we can access a lot of things. I'm going to hide it for now and just use my computer keyboard. F of x equals, oh, but I need the square root function, and I don't have it, so here it is. So I can bring up the keyboard, and then I can just type x, or I could use this x minus 4, right? That's what we have in there. And then we see the graph. Nice with Desmos, we can grab it, move it around. We see that there's the graph, in this case purple, going off in this direction. So what it means is, if we click here, we see that the point 40 is included on the graph. It's part of the graph. Go ahead and label it. And so what we end up with is, what are the x values that produce a real value y? And what we see is that goes from the point 4 that's included all the way over here. As we keep going off towards infinity. So that's going to be our domain. It's everything in this direction, right? All of these x values produce some kind of a y value on the graph. Anything on this side, going this way, is not in the domain, because there's no purple graph here. There's no y values. None of these x values work, so that's what it's going to be. Let's also look at this from the perspective of a table. So I'll come here, I'm going to go to the table, and I'm going to insert a table, and what I'm going to put in this table, the same thing, is I'm going to put in x1 and the square root of x and then 1. Notice it'll automatically make that minus 4. So I've got the function in here, and maybe I could put in f of x. I don't know. That might work. Let's see. Could I just have put in f of x? No, that doesn't work. Okay. Just try things, Square root of x1 minus 4. And now you don't see much of anything, but you can start putting in values. Let's put in 0. Well, that's undefined, right? Because if x is 0, there is no y value. Okay, how about 1, 2, 3? I'm just hitting enter, and it's going to give it. Oh, as soon as I get to 4, I do get a y value that is a real number. And 5 and 6 and so forth and so on, we're getting y values. So this is another way to look at the domain. The domain is 4 is included, and all the numbers bigger than 4 are included, but anything smaller than 4 is not included. So that's the idea of the domain. Now, analytically, how do we go about doing that? Well, we just take our setup here, sort of our first step, take the what I call the guts of the square root, where everything inside the square root, make sure it's going to be greater than or equal to 0, and then we solve for x. So we add 4 to both sides, and then we get that x is greater than or equal to positive 4. The next step, once you've solved for x, is to put it on a number line. This is sort of, think of this as the x-axis, right? 4 is included, and that's the same thing we've done over here on the Desmos graph. Here's 4. 4 is included, so it's a solid dot. X is greater than 4. That means it's to the right of 4. So it's all these numbers here, and it never stops, and so we're shooting for infinity. 4 is included, going to infinity. So there's um, our interval notation. A bracket on the left side, a parentheses on the right. So we choose this one. We put in our number 4, and then we put in positive infinity over here. Okay? And that is how we do this domain of a square root function basic.